right, hello everyone. Welcome to our live science stage here at Pacific Science Center. My name is Katie. Today we are here to learn all about super cold things. So before we get started, let's take a second. We're gonna think of some super cold things and some super cold places. Let's take a second. Ooh, did we think of any? My favorites are things like popsicles, Antarctica, sea ice, lots of really cold things. I even have brought with me a super cold thing today. We call it liquid nitrogen. Now, to do experiments to figure out what cold things do and how they act, we need to use a super cold thing. So, liquid nitrogen is so cold that it is negative 319 degrees Fahrenheit. That seems really cold. I don't think I've seen a temperature like that here on Earth before. But we are being scientists today, and scientists like to use something called Celsius to talk about temperature. Can you say that with me? Celsius. So that number in Celsius is different, but it means the same thing. We call it negative 196 degrees Celsius. Both numbers mean super, super cold. So, if we are going to use the super cold liquid to do some experiments, we need to think about how to be safe around it. For example, I have safety goggles and safety gloves. If you do not have safety goggles and gloves, that means you should not do experiments with the liquid nitrogen. Thankfully, we're good today. We also need to make sure that I am being extremely safe, so I want to try an experiment. If we're going to try an experiment, I'm going to put on my safety goggles. I'm going to put on my safety gloves. Actually, before we do that, let's try something. Instead of putting any old thing, if I wanted to put my hand into the liquid nitrogen, that doesn't sound safe. But a glove sounds better. So let's make our glove look a little bit more like a hand here. There we go, that's better. Now, if we are gonna put the glove into the liquid nitrogen, we should probably give it a name. I don't know, I think Handy sounds like a good name. Everyone say, "Hi, Handy!" Here we go. Now, to put Handy into our super cold liquid, we need to figure out how cold this liquid is. So we are gonna put Handy in for 3 seconds. I need your help at home. We are gonna count to 3. Here we go. Ready? 1, 2, 3. All right, that looks pretty good to me. Good counting at home. Let's see him. Uh-oh. Something happened to Handy. I think this liquid is super, super cold. So we definitely need to be safe around this liquid. So let's do it. But that was kind of cool. I kind of like that Handy broke into lots of tiny pieces. That means that we should do more experiments. Now, to do more experiments, I want to introduce you to something. I have brought with me solids, liquids, and gases today. We call these things the states of matter. And matter is really cool because matter is just everything. Everything is made of matter. I am made of matter, and you are made of matter. Even things like rocks are made of matter. And matter can be broken down into even tinier pieces, kind of like Legos. Now, if you like Legos, raise your hand at home. Who likes to play with Legos? I thought so, me too. So these Legos that make up our matter we call molecules. Everyone, let's say it together. Molecules. Great job. Now, these molecules, depending on whether you are a solid, a liquid, or a gas, act differently. So it has come time for us to have a molecule dance party. Let's start with solids. Rocks don't really move around all that much, but they still like to dance. So everyone, strike your favorite pose. What's your favorite pose? Good job. Keep striking. Don't move. And you all make beautiful solid molecules. Excellent. Now, if we want to move on to liquids, liquids move a little bit more. So liquid molecules like to flow back and forth. Can everyone flow back and forth like a liquid molecule? Excellent job, wonderful. But last but not least, we have gases. And gases are personally my favorite because everyone take a deep breath in and let it out. Gases are all around us, but they also have the most energy and take up the most space. Gases are the craziest dancers of our group, so everyone together, everyone dance crazy like a gas molecule. How far can you go? How fast can you move? Those gases are pretty cool. But if we take these molecules and we get them super cold, we should figure out if they act the same or different. So everyone take a guess. If we put gases, liquids, and solids into our super cold liquid, are they going to act the same or different? Let's find out. To start, we are going to use the gases because, like I said, they're my favorite. Once again, everyone take a deep breath in and let it out. Now, gases, I said, are all around us. We breathe them in. If you take your hand and go like this really fast, you can feel them too. But we can also trap gases. You may have used this before, but I have brought with me a balloon. And normally with balloons, we blow them up. So let's go ahead and do that. There we go. Now we have lots of Katie gas inside of our balloon. We have air, things like oxygen, carbon dioxide, nitrogen, water vapor. There are lots of different kinds of gases in here. But all of those molecules are moving around and pushing like crazy. I say we get it cold and see what happens. So, to get it cold, I'm gonna put my safety gear back on, and we are gonna put the balloon into the liquid nitrogen for 10 seconds. But those of us at home, as scientists, we have to make predictions. We have to make guesses on what will happen. So go ahead, make a prediction. What do we think might happen to the balloon when it gets really cold? I don't know, some of my guesses are maybe it might pop, maybe it might turn purple, maybe it might start flying in the air. We'll have to find out. So let's count together. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well, wait, hold on. Our balloon is making a funny sound that it didn't make before. I think we might want to take this out and see what happened because that was kind of a weird noise. So let's see. We need to use our eyes to make some observations. So does the balloon look the same or different? Let's find out. Whoa. That's a little bit different. It's much smaller. It's like it shrunk. But there's also stuff in here. There's liquid in the balloon. Okay, well, there wasn't liquid before. Maybe I spit in the balloon. I don't remember doing that, but whoa. Hold on. It's not small anymore. It blew itself back up, and now there's no liquid. There's just gas. Okay, hold on. Let's think about this. Let's think. Because inside of our balloon, we have gases. So remember, everyone, gas molecules act crazy, so please dance crazy like a gas molecule. Yes! But I don't know about you. When I get cold, I kind of go like this. Does anyone go like this when they get cold? Yeah. Molecules do the same thing. When they get cold, they take up less space and they slow down. Now, crazy gas molecules, when they slow down, they start flowing back and forth. Everyone, flow back and forth with me because we just turned into liquid molecules, what we saw in our balloon. And liquids don't take up as much space, so our balloon got small. But the balloon got big again, and which means it got warm. So everyone, flow back and forth like a liquid. But now, just like the balloon, we're getting warmer, so we go faster and faster and faster and faster until you're dancing all crazy again. And our balloon blew itself back up. I think that's pretty cool. Let's give balloons a big round of applause. Woo! Thanks, balloons. Thanks, gas. Pretty fun. Now, if we get gases cold and it gives us liquids, I say that we freeze some liquid next. So I have brought today with me some liquid water. Now, water is very important. So if you have not already had water today, go ahead, pause the video, go get yourself some water. Water, very important. But an experiment you might have tried before, if you take water and put it in the freezer, it gets cold and turns into ice. But I don't have a freezer with me today. All I have is the liquid nitrogen. So I say we take a cup of liquid nitrogen, put it into the water, and see what happens. I say we do it, so let's try. All right, now, if we don't have a freezer, we're gonna have to see. So let's make a prediction again. Are we gonna make ice? Is the water gonna get cold? Could we potentially turn it rainbow colored? I don't know. I say we find out together. Now, for this one, we need to count down. We are gonna start from 3. So here we go, everyone, together in 3, 2, 1. Whoa. Well, that's pretty cool. It doesn't look like ice, though. All this stuff is moving around. Kind of like gas, because we have created gas. Liquid nitrogen is so cold that not only does it freeze liquid water in the cup, it freezes water vapor in the air and turns it into clouds. But is this gas going up or down? You're right, it's going down. Gases that are cold, like fog, go down. And gases that are warm, like steam out of our baths and showers, goes up. So we've created a cold gas. But not just gases in here. Let's take a look to see what else. So we have gas, but what else do you still see inside of our container? Yeah, I see gas, I see liquid, but we said that when water gets really cold, it turns into ice. I don't see the ice. And we also said that it's probably not a safe idea for me to put my hand into liquid water. But I have another experiment we can try. When ice breaks, it makes a sound. I'm hearing a couple of sounds, but let's see, if we break the ice, does it make a sound? Did we hear it? I sure did. There is ice inside. We have gas on top, we have liquid on the bottom, and then solid ice right in the center. We've made all 3 states of matter inside of one container. It kind of reminds me of a sandwich. Gas on top, liquid on the bottom, solid in the middle. It's a state of matter sandwich. I think that's pretty cool. Let's give our sandwich a round of applause at home. Oh, good job. Thank you, sandwich. Oh, yes. Now, this is pretty cool. We were able to take that liquid. Now remember, everyone, liquid flows back and forth. Let's do it again. Flow back and forth like a liquid. But now we're getting cold. And when molecules get cold, they take up less space and they slow down and stop, turning into solids like ice, kind of like rocks. Remember, solids don't move that much. So we've done gas, we've done liquid. That means we have solids left. So solid molecules, remember everyone, we just said, don't move that much. But some have the ability, like this tube, to stretch and bend. And we say things that can do this are elastic. Let's say that together. Ready? Elastic. Now, my favorite elastic things you all have with you right now. Everyone, please flex those muscles. Show me those muscles. Yes. Now we're going to take your muscles and flex them forward, backwards, one side, another side, back and forth, round and round. Yes, our muscles are elastic. They stretch and bend just like our tube does. Now, if we wanted to do more experiments with something that's elastic, this may be something you have at home too, but I want to use a bouncy ball. Oh yes. Now normally bouncy balls bounce, so let's see. Did it bounce? It sure did. Now, scientists have to try their experiments more than one time to make sure they get the same answer every time. So let's try again. We'll be scientists. Did it bounce? Yeah, it did. And it bounced. And it bounced. Excellent. Our ball bounces. Now, scientists also have to try more than one experiment. So our ball bounces, but if I tried really, really, really hard to tear the ball into pieces, okay, I can't tear it into pieces, no one has, but it still bounces, it's in one piece, so that experiment didn't work. But sometimes scientists also use tools, and I brought a tool. If I hit the bouncy ball as hard as I can on the rock, let's see what happens. Ready? Oh, okay. Well, it still bounces. It didn't break on that either. It stretches, it bounces. I say we get it super cold and see what happens. Let's do it. So, to get our ball nice and cold, I thought ahead for this one. I put a bouncy ball in here before we started to make sure it got nice and cold. I say we take it out. Oh yes, it looks very cold. We're gonna take it out, see if it acts the same or different from our other one. So let's take a look first. Here we go. We have our bouncy ball. It's still round, it's still blue, but it has some frost, it has some gas coming off of it. That gas is going down because it's cold. But let's see if it still bounces. Let's try that. So here we go again. We're gonna count down together. Ready, 3, 2, 1. Uh-oh. That didn't really bounce all that well. Okay, well, let's try again. We said scientists try their experiments more than once. One more time. Here we go. Ready? 3, 2, 1. Okay, well, that one didn't really bounce either. But let's try one of those other experiments. If I try to tear the ball into... Okay, well, it's even harder now. But if I hit it on the rock... Oh, uh-oh. We have a slight problem. Oh, man. My bouncy ball broke. You won't tell me when I broke that, will you? Okay, good. That's our little secret. We'll share that together. But my bouncy ball broke and the other one didn't. Let's think about this. So, we said before, solid molecules don't really move. So everyone, strike your favorite pose for me again. Strike your favorite pose. Arms in the air. But we're getting cold, which means we're gonna take up less space. Bring those arms in. We are gonna slow down and we're gonna bring in all of our body parts to be as small as we can, just like cold, solid molecules. They get so squished together that they become really easy to break. That's why our ball broke, and that's why the ice broke when we squished it. Oh my goodness. I say we give solids a big round of applause. Oh, great job, solids. Excellent job. Now, we've talked all about gases. We've talked all about liquids. And now we've talked all about solids. When gases get cold, they slow down and turn into liquids. And when liquids get cold, they slow down and turn into solids. And when solids get cold, they slow down and turn into, well, even more solids. But that means that we have time for one final experiment today. If you'd like to do one final experiment, please, at home, put your hands in the air just like this. Oh, yes. And then wave those hands around. Great. Let's do it. All right. We will get set up for our last and our final experiment of the day. So, I figured that our last experiment should be the biggest experiment. Sounds good to me. I figured our last experiment should be the coolest experiment. Absolutely. So I figured our last experiment should try to send things flying into the air. That sounds pretty cool. So, in order to do this, I have brought with me my pipe of science. Can everyone at home say, "Hi, pipe"? Great job. So our pipe holds 1 cup of liquid nitrogen, the amount that we poured into the water earlier. And when we poured 1 cup of liquid nitrogen out, the first thing we saw was gas. When liquid gets warm, it immediately expands, takes up more space, and all of those liquid molecules that are floating back and forth start to go crazy, just like inside of our balloon. So, 1 cup of liquid nitrogen turns into over 700 cups of nitrogen gas. And I don't think that my pipe holds 700 cups of gas. That seems like a lot. But I really, really, really want it to. So I figured that if we wanted to make all the gas stay inside, all we have to do is put a cork on top. And that will definitely keep the gas inside. Okay, hold on, I'm thinking of a problem with this. If it keeps all the gas inside, great. But if it doesn't, all that gas is gonna push everywhere, and it's gonna push the cork flying into the air. Well, that sounds like fun. I say we still try that. So, we need to get set up for our last and our final experiment, which means I need some help from you at home. Now, my friends that are at home, we are going to attempt this experiment, and I'm going to be so focused on trying to stop all the gas inside that I need your help to count how many corks it takes. So let's take a guess. Do we think that it will take at least 2 corks to stop the gas? Maybe. What about at least 5 corks to stop the gas? Well, let's find out. We need to get our cup of liquid nitrogen. We need to get ready to count together. This is gonna be our last and our final experiment today. So thank you for joining us to talk all about the states of matter. Are we ready? I'm ready. So let's pour in our cup of, well, hold on 1 second. This is already gassing. That happened so fast. Okay. Well, let's make sure it's nice and full. Get all 1 cup in there, 700 cups of gas, and we're gonna stop it. Like, oh my goodness, like that. Okay, not 1, 2. Oh goodness, 3 for sure. Okay, 4 it is. No, not 4. 5, not 5. 6 it is. Oh my, 7. Oh my, 8. Oh, they're falling. You know what? We did it. It took 8 corks to stop the gas. Let's give it a big round of applause, everyone. Great job. Thank you for joining us to talk about solids, liquids, and gases. I hope you all continue to do the molecule dance at home. Enjoy the rest of your day. Bye.